What's going on, guys? Welcome back to a new video. Today we're going to be learning about discrete math functions. So given a function, sorry, this is given, oh no, just give a function from n to n that is 1 to 1 but not onto but not 1 to 1, both or neither. So for 1 to 1 but not onto, um, we can simply just put, I'll just use it right here. We can simply just put x is equal to, let's say, n plus 1. Now, why is this 1 to 1 but not on 2? The reason being, the sole reason is because when you look at it, right, if you're mapping n, say this is n, and then say this is the destination. So if you're mapping it, let's say this is 1, this is 1, 2, 3, okay? So you're gonna map 1 to 2, right? Because it's n plus 1. So what happens is you're essentially just mapping it 1 below. So you're always gonna miss out on this one. And even if you had, let's say, a -1 right here, so sorry, not a -1, I mean, say you had a 0 right here, even if you map it here, this -1 up here won't be mapped, so you'll always have one left out. So before I do the next one, I want to really define what 1 to 1 and onto are. So 1 to 1 means when, let's say you have A, B, C, D, and then 1, 2, 3, 4. So 1 to 1 basically just means, it's all, every single one of those is taken up. Or no, that's onto. That means that essentially every single one has one map to it. So let me go ahead and make this a little different. Let me just erase the D right here. Yeah, let me just go ahead and erase the D. Okay, so this is still 1 to 1 because you're not having to essentially, each one has one thing mapped to it, right? It has one thing mapped to it. Even though 4 doesn't have anything, that doesn't matter. Like, each one has one thing, so it's 1 to 1. But on 2, that's different because essentially, let me show you on 2. So on 2 would mean that every single one is taken up, essentially. So let's say you had an E right here, and then you put this, okay? This wouldn't be 1 to 1, but it would be on 2 because every single one of these are occupied, if that makes sense. And then, so if you want a function that is on 2 but not 1 to 1, what we can use is actually n divided by 2 and just have the ceiling of that. So it would just be f, well, I don't know why I put that x right here, but f of n equals n divided by 2, and then you take the ceiling of that. Why is this onto but not 1 to 1? Well, think about it logically. Okay, let's go ahead and take this and work it out right here. Let's go ahead and work it out right here. If you have this, right, n divided by 2. So just take a random number. Let's take 2. If you take 2 and you essentially 2 divided by 2 is 1. Then you take the seal of that. Now remember, seal basically does, if you have 1.1, it's going to become 2. If you have 1.9, it's going to become 2. Like, it doesn't work the same way as rounding does, but seal is really nice. It just basically bumps it up to the next number. So it's nice in that regard. So here, it would be n divided by 2 because this is on 2. How is this on 2? You may ask. Well, let's think about it logically. You have the n that's being divided by 2. That part doesn't make it on 2, but if you have a seal, that part now makes it on 2. So I'll explain how that is. So if you have, say, A, B, C, D, A, B, C, D. So if you have this, then how you can simply just do it is go ahead and just do it. I don't know why I'm using letters when it's numbers. Sorry, guys. 2, 3, 4. 1, 2, 3, 4. Okay, cool. Now look at it this way, okay? So if you have, let's say you had 1, okay? N is 1. If you have n is equal to 1, what happens is, if 1 divided by 2, now take the seal of that, so 0.5, and then you take 1. Cool. Now let's do 2. 2, again, it's 1. Cool. Take 3. 3 divided by 2 is 1.5. That gets pushed to 2. So, essentially, this isn't 1-to-1 ever, because 1 and 2 can have the same output. So it can't be 1-to-1 ever. It is on 2. The reason being, well, right here, every single number is going to map to something, always. So that's really what makes it on 2. And I'm going to just get rid of all of this real quick. But yeah, that's how I essentially got it. And then for both, now this is a tricky one. How can it be both 1-to-1 and on 2? Well, think about it this way. You will have f of n equals n minus 1 for even, and f of n equals n plus 1 for odd. So let's do the first one first, the even one. So if you have, or let's do odd first, since 1. Yeah, so let's say if you have 1, f of 1 is equal to this one, so it should be 2, which is good. Then if you have, let's say, an even number, so f of 2 equals 1. So it's always going to map to something, and it's going to be both 1-to-1 and onto at the same time. And then for the last one, for neither, you can just simply have it equal to a constant. So we can do f of k equals k for some constant. So you can have f of k is equal to, let's say, like 12. That would make it neither, because if you have it equal to 12, you're essentially looking at this. You have, say you have 12. and 12 can only go to 12. Cool. Now what if I have, let's say, I had all of these. None of these get touched. None of those get touched. So if you have a constant, it would just be neither. So constant is neither. So just to review, 1 to 1 is basically, you can have it 1 to 1 but not onto is n plus any number, like let's say 13. N plus any number is always 1 to 1 but not onto. Onto but not 1 to 1 is n divided by 2, and then the CL function. For both, you can do n minus 1 for even, n plus 1 for odd, and then for neither, it's constant. So that's going to end it right here. Thank y'all for watching and have a great day.